So now let's look at function notation. Function notation is just a concise way of representing relationships between elements in a set. You've already been using this kind of intuitively and just not naming it, but every time you do something like this, y equals 2x plus 5, you are actually using a function, because for each value of x, I get one value of y. Now function notation is just a modification of this in that instead of writing y, we write f of x. Okay, so this stands for f of x. And unlike variables x and y, which you're used to seeing to represent numbers, f here does not represent a number. F is like the connection between x and y, so it's a little bit more abstract than that. Okay, how do we use this? Well, let's say I wanted to evaluate the value of the function at 1. Okay, well, I would just plug in 1 for x on the right hand side and evaluate. So this will give me 2 plus 5. So we say the value of f at 1 is 5. I'll write that down. The value of f at 1 is 5. Now, why is it f? Well, we use f because f stands for function. I can use any letter I want. If I wanted to, I can use the letter g. I can have g of x equals 2x plus 5. I could have h of x equals 2x plus 5. It's up to you what you want to do, okay? Just like x is conventionally used as a variable, f is the letter conventionally used as a function. And you're free to change them up as much as you want. Usually the function letter that we choose will represent something in the situation we're looking at. For example, if we're looking at the height of something, right, that depends on some kind of variable x, we'll call the function h, right? If we're looking at a distance function, let's say distance as a function of time, right, I'll write t for time instead of x. And then we'll have some kind of equation, I don't know, negative 4.9 t squared plus 9.8 t minus 5, and you get a quadratic function. So function notation is just a way to write a function in a concise way that shows the dependency of one variable, let's say d in this case, on another. Okay, you'll be using this pretty much from here on in for the rest of your mathematical career. Everything is basically seen as a function for the most part.